Hello, welcome to Getting Started with ClickHouse. My name is Rich Raposa. I'm on the training team here at ClickHouse, and I'm super excited that you're getting started with ClickHouse. This particular training course is meant to be the launching point, the beginning of your journey as you learn how to use ClickHouse and become an expert at it, which is definitely our goal here at the ClickHouse Academy. This particular training, we're going to talk about really what is ClickHouse, what's an OLAP database, why is it different than maybe something that you've used in the past. We'll talk about column-oriented storage and why that's so nice to have, what makes that so efficient for analytical type queries. And then we'll get you started with ClickHouse. I'll show you how to use ClickHouse Cloud, and then I'll also show you how to download the ClickHouse binary, which is super simple to do. You can run ClickHouse, you can run the ClickHouse server locally on your laptop. And then we have some great labs. All of our trainings start with nice videos. And then at the end of the training, you can watch videos all day long. It's the labs is where you're really going to learn ClickHouse. And so we have some great labs for you, just like we do in this chapter. For what it's worth, this is the beginning of a 12 module training called ClickHouse Developer. The goal of the ClickHouse Developer learning path here is to make you a ClickHouse certified developer. If you're interested in taking the exam at the end of this journey, there is a certification exam. It's a hands-on performance-based exam that you take. So anyway, keep in mind that you're just here at the beginning. We kind of go through a very logical flow through the 12 modules with how does ClickHouse work in chapter 2 in terms of how it stores data, then the modeling of the data, you put the data in, you analyze the data. We spend a lot of time on optimizing the data with things like materialized views and projections and skipping indexes and how joins work and all those great things. So good luck on your journey. And of course, if you have any questions, please feel free to reach out to us, learn@clickhouse.com, and you can find us on Slack at clickhouse.com/Slack. So let's get started with ClickHouse. And I'm going to start at the beginning with what is ClickHouse. ClickHouse is a database. It's a database management system. Its name actually is derived from, or short for, Clickstream Data Warehouse. That was its initial use case, was clickstream data, which is a massive amount of data. You do a lot of analysis on it very quickly, lots of grouping, lots of filtering. So that was sort of the initial use case for what ClickHouse is. It's an OLAP database, and that acronym stands for Online Analytical Processing, but the key letter there is the A, the analytical. ClickHouse is for analyzing data. It's not an OLTP, an Online Transactional Processing database, which is for doing transactions. ClickHouse is all about lots of data and analyzing large chunks of that data very quickly. And it's fast. It does parallel processing. It distributes everything across multiple machines. Whatever you throw at ClickHouse, it'll use. If you have a terabyte of RAM, ClickHouse will use the whole terabyte of RAM if it has to. If you have 128 CPUs, ClickHouse will use 128 CPUs if it can or if it has to. It consumes and uses whatever resources you give to it. And so you compare an analytical query in ClickHouse to an analytical query in something like SQL Server or Postgres or whatever your favorite other database is. ClickHouse is hundreds of times faster, often 1,000 times faster than what would be considered a row-oriented database. Now, OLAP and column-oriented don't necessarily go together, but in a lot of cases they are. And I'll talk about column-oriented here in just a little bit. But I get asked this question all the time, especially people new to ClickHouse, is like, what's the big deal? Why should I use ClickHouse versus what I already have? Well, ClickHouse is a real-time data warehouse. And so, for example, Disney Plus generates massive amounts of data. They have like 100 terabytes of logs, and they need to query that data very quickly. They scan over 2 billion rows per second in their application. And you can read about all of these, what I'm about to show you, all these use cases are on our website, and we'll have links below the slides when you go through this in the training, that if you want to read the details on all of these. Cloudflare is putting in 8 million rows per second. They capture all the network packets and analyze them. This is 7 times faster than their previous framework that they were using. And so for them, this real-time analytics is possible with ClickHouse when it wasn't really possible with their previous systems that they have. For example, eBay has over 1 billion events per minute. And they were using Druid, and it was too costly to maintain. They got 90% fewer machines and resources to do the same thing with ClickHouse. Uber was using the Elk stack. They couldn't even get all their logs into it. They're using less hardware. reduce their cost by half using ClickHouse, and the logs can be ingested 10 times faster. Both Deutsche Bank and Rokt are using it for business intelligence. Deutsche Bank is a bank. You can imagine they have all kinds of reporting that they have to do. Rokt is another Elasticsearch user that switched over, but they were also having performance issues with Redshift, and they saw huge performance benefits from ClickHouse as well. And then, of course, we have to mention machine learning and Gen AI. DeepL is using ClickHouse as their central data warehouse, and AdMix are very similarly training all their models with all this data. They have to aggregate over 1 billion unique users a day, and so they are they came over from SQL Server and Azure Table Storage. So again, read about all those. I got the links I'm going to share with you. So that's kind of what other companies are using ClickHouse for. And, there's lots of use cases for ClickHouse. That's just sort of a very high level sort of run through of what you can do with ClickHouse. Let's take a look at how it works. It's a column-oriented database. Well, what does that mean? Well, you're probably familiar with a row-oriented database. You insert a row. And by the way, in ClickHouse, you still insert one row. You insert a row with the exact same SQL statement that you do with a row-oriented database. Something like Oracle and Postgres, they're going to save that data as a row. It looks like row 102 is a Samsung Galaxy, and it's got an ID and a description and whether or not it's unlocked and the price. That's all going to get stored together in a row-oriented system. And if you want to know what the price is of phone number 102, well, the data is all together. It's easy for those kind of databases to pull out the price of a single cell phone. And so that's what row-oriented databases look like. A column-oriented database stores the values of the columns together. So you insert the rows just like you do with any other database. ClickHouse is going to take, for example, all of the IDs, all the values of the IDs, and separate them out and put them into a single file. And so that file is just going to have a bunch of what looks to be like integers. And if you think about that, if it's just a file with integers, that file could be compressed very easily. I mean, that's the only thing it has in it. We don't store metadata or anything extra in these files. It's just the values of each row. They compress nicely, they uncompress nicely. That's very easy to find values inside there. It's quite a wonderful way to store the data. So the strings, the descriptions, they'll be in a file. These unlocked ones and zeros will be in another file, and then all the prices would be in a fourth file. And ClickHouse doesn't really over-engineer too much. Like the name of the column will actually be the name of the file if you looked at the files on your file system. And so that's what a column-oriented database looks like. Now, if you want to know what the price is of phone number 102, well, if you think about it, you kind of have to piece that back together. ClickHouse has to figure out that 102 is the second row, and then it's got to go find the price file and open that up and find the second value in that file and so on. So reconstructing the rows can be a bit of effort, but don't sit there and think that it's slow. It's not slow. I mean, ClickHouse could retrieve one row so fast you wouldn't even know it happened. But it is something to be aware of, that we don't just randomly select all the columns. We don't normally ask a question like, what is row number 2, or why would I, what is the price of phone number 102? That's not an analytical question. An analytical query looks more like this one. What is the average price of all my phones? And forget the fact that I only have 4 prices on the slide. That's all that fits. I'm trying to just demonstrate this. Imagine if I had 4 million rows or 4 billion rows of these floating point, these decimal numbers, and I wanted the average price of the 4 billion rows. Well, ClickHouse can do that in a ridiculously fast, way. And it's just super quick when you're asking these kind of questions, and it can just answer them for you right away because all the data is right there in one file. And even if it's split across multiple nodes and it's in multiple files, it's still ridiculously fast. And these are the types of analytical queries that really pay off with a system like ClickHouse. So you've written your SQL queries in other databases, and I suppose a really obvious sort of good question to ask is, will those queries run on ClickHouse? Well, absolutely. For the most part, ClickHouse strives to be an ANSI SQL standard. Now, not everything, works its way into ClickHouse, but for the most part, if you know SQL at all, you'll be very, familiar. It'll be very easy for you to write these queries on ClickHouse. It's the exact same syntax. The difference is you're probably going to ask different questions. The queries that you might have written for your MySQL database probably aren't going to be the same unless you're migrating an application over or something, in which case it's great to compare the two speeds, by the way. And we do things a little bit different in column-oriented type databases. We don't select all the columns unless we need them. Joins work fine. You run your favorite joins. You just need to understand how they work. And we have a whole chapter on joins coming up later in this learning path. Like I said, OLAP's for answering questions. So your questions are often a little bit different. ClickHouse has a lot of functions. It has over 1,400 built-in functions that aren't a part of the standard SQL at all. And so that's really, your queries will work on ClickHouse, but you'll probably at some point in time want to take advantage of some of these great functions that we have. And then that last bullet there talks about a table engine, and that's how the tables store their data. That's a bit unique to ClickHouse, and so we'll have to talk about that as well. Now the data types are a little bit different. All the ANSI SQL standard data types work in ClickHouse. You can use varchar, you can use number, int, blob, clob, whatever you want. They all just are aliases to one of the built-in ClickHouse data types, and we'll go over these in great detail when we create tables in one of the upcoming lessons here. But I just wanted to point that out, that the data types, they're not necessarily standard SQL data types. You can certainly use the standard SQL data types, but I'll use the built-in ClickHouse ones. One nice feature of ClickHouse is how it can read data wherever you have it. And not just where, but what the data is. So let's say you have a Parquet file sitting up in S3, for example. Well, we have a bunch of table functions. One of those table functions can read from S3. We read dozens and dozens and dozens of file formats. We can easily read a Parquet file. And so in ClickHouse, you can just query wherever the file sits, you can just query it, and you don't even have to put the data into ClickHouse. You can run these sort of ad hoc queries. It's a great way to sort of look at data, run ad hoc queries. It's a great way to also get the data into ClickHouse. Once you're ready to take that Parquet file or those, that bucket in the cloud full of Parquet files, you want to put that into a table in ClickHouse. Super easy to do. And we have lots of table functions, whether it's S3 or Google Cloud Storage or Azure. You want to pull data out of Postgres or MySQL or SQL Server, or I don't care. Doesn't matter. Database, Kafka, all kinds of sources of data can all be pulled into ClickHouse using one of the many table functions that we have. So keep that in mind. We have a whole discussion in the upcoming module on ingesting data. All right, so let's get started. Let's take a look at ClickHouse Cloud. Now there's a couple ways to get ClickHouse up and running. You can easily download the binary if you're just playing around on your laptop and you want to, just get up and running. I'll show you how to do that. And I'll also show you how to get started with ClickHouse Cloud. Super easy. What's nice about ClickHouse Cloud is if you're building a POC and you need something pretty substantial to do that, you're going to immediately get a large cluster of nodes with all kinds of memory, all kinds of disk space. And it also comes with all the things you would expect from a cloud service: security, the backups, the high availability. It's just all ready to go with the click of a button. And so actually, as we go through, you'll see all the labs are written on ClickHouse Cloud. And I'll get you started. We'll go through this. So let's create a new service. I'm going to go over to clickhouse.cloud. Now I'm already logged in. All you have to do is log in. You can log in with your Gmail, your Google account. It doesn't matter how you log in. You can create a username and password if you want. You can see I have a couple of services. You won't have any services, obviously, when you start. But let me click on New Service. And this little window pops up. Notice I can pick AWS. I can pick GCP. But right now, Azure is coming soon. So notice you can join the wait list if you want to be notified when Azure is available. I'll click on AWS, and I'm going to call this instance, you give it a name, I'll just call it ClickHouse Fundamentals. There's an idle time. You can set that to 5 minutes if you want to keep your service, from consuming too many of your free credits right away. You get 300 free credits for the first month. I'll leave mine at 15 minutes. Actually, I'm going to set mine to 30 minutes because I kind of disappear and come back quite a bit during the trainings, and I don't want to have to wake up my service, which takes a few seconds. Very important. You can pick a production service. That's unlimited disk space, all kinds of memory, 24 gigabytes of memory, all the way up to whatever you need. If you're just trying to get started here, the development is good for doing the labs in this training and so on. So that's what I'm going to do. I'm going to pick the development instance, and I'm going to create the service. The first thing it's going to ask you is how to connect to it. This is a security question here. Do you want to open it up to the world, which we don't recommend? You can see it says, don't do this. it's super easy to just click specific locations. Notice that's my laptop's IP address. So that was, at least right now, that's its IP address. So it'll add that, and that's the only way you'll be able to connect to it. So sure, you're looking at my password right here, but I'm not worried about it because you can't connect to it unless you're on the IP address that I've allowed. So I'm going to save my password. I guess I can copy it up here. That's probably easier. And I'll back that up over here somewhere. So notice here, I'll copy the curl command, and then I'm just going to swipe over here to my terminal screen, and I'll paste it. And like I said, it figures out your operating system, downloads a compressed file. So the first time you run it, it takes a second. It takes a half minute. It's got to unzip the file and start up the server. It doesn't take long to download. Obviously, it depends on your internet connection. Okay, so there you see I have it downloaded. We can see the file sitting there. And if I run ClickHouse server, this will just run it right here on my laptop. Like I said, it has to uncompress the file. And then the very first time you run it, it creates a bunch of folders that the server needs. For example, the config folder, the data folder, some folders for you to put user files and executable scripts and so on. All that's happening right now. And so the very first time you run it, it just takes, I don't know, maybe like 20, 30 seconds. And so I'm going to let that run. By the way, if I go back over here to my cloud service as I do these things in parallel, you can see that my cloud service is running. I can, if you look at this little command right here, I can copy and paste this ClickHouse client command. And if I've downloaded the binary, which I have, I can go over here to my terminal screen while my server's up and running, and I can just paste it. Now, before I paste it, I'm going to run ClickHouse client right here on my laptop. So I have the server running on one tab. I opened up a new tab, connected to it. This ClickHouse client is connected to localhost. You can see this Rich's MacBook Pro 2 here. And I can run commands here. It's nice. I can run commands at the smiley face prompt. I can show databases. I can select, I can show the tables in the system database. It looks like there's a database called system, and it looks like, at least locally, there's 88 tables in this so-called system database. We'll talk more about that in the next chapter. I'm going to exit that, and then I'm going to paste the ClickHouse client command that was over in the cloud UI. Now I'm connected to my cloud instance, and I can do the same thing. I can show databases. You'll notice the same for databases. That default database is empty. That's where your tables will go when you create a table and not a specific database. That system database has some super handy tables. This particular deployment has 101 tables in it. And like I said, I'll talk about some of those tables later on, but just, I suppose, quickly to see it. There's all this read-only information about what's happening on your service. And so it's super handy. All right, let me go back over here. I want to show you one more thing. I'm going to click this button right here and open the SQL console. Now, this is where I'll spend most of my time. I can run queries from the terminal, no problem, but I'm a big fan of the SQL console. So let me zoom in a little bit and notice I can open up a new tab and I can run queries right here. I can say show tables in system, and I'm hitting Command Shift Enter on my Mac. And there's the 102. I don't know why it's one off. 102. Oh, 102 rows. I thought it was 101 over here. Wow, a table got created in the last minute or so after I logged in. Oh, probably maybe a table. I don't know what that is. That's interesting. All right. So there's the SQL console. Like I said, I'm a big fan of it. Now, here's what I really want you to see. So that whether you run it locally or run it in the cloud, that's fine. Please keep in mind all the labs are written for the cloud. It's just so easy to spin it up. And there's just a lot more fun things you can do with the cloud because it's actually a cluster. And so you'll sort of learn more details as we go through it. I have an S3 bucket sitting here with a bunch of Python files in it. They're not Python files. It's a data set of Parquet files that contain downloads of Python libraries. It's the PyPI dataset. And so we have hundreds and hundreds of these Parquet files. I'm just going to pick one. I just want you to see how easy it is. I'm going to copy the link. Now this is a public file up in S3, so I don't need credentials. I just want you to see how easy it is to write these queries, to grab data. So for example, I can just select star, and I'll use the S3 table function from that URL. And I don't want to grab the whole thing. I'll just grab 100 rows or something. hey, this is pretty cool. I'm querying this file that's up in S3 and, and I don't have to download the file. I don't have to, put the file into a table. The S3 table function creates a table-like structure for me. So for example, and I'm just going to copy that whole thing. I'm going to treat this like a table, which means you can do things like you can describe it. You can see how ClickHouse infers the data types. Whoops, I didn't want the from there. You can see how ClickHouse infers the data types. Well, from a Parquet file, the data types are in there, so it's pretty straightforward. But these are the column names inside here. And like I said, these represent Python projects. So the project column is the name of the project, and then the timestamp is when it was downloaded. So for example, I can select, well, let's do like a count. So let me select the project, and then this will be the number of times that it was downloaded. And I can select it from there, and I'm going to group by project, and we'll see what the downloads are, the number of times that each Python library was downloaded. So OS Brick was downloaded 4 times, FASM was 6. Oh, that's kind of boring. Here, let's find out the big ones. Let's order by, well, project is column 1. I'll just give this an alias, so I don't have to explain that. I'll just say order by C descending. I could have put order by 2 descending because it was the second value there. So Bot03, which is, that library is far and away the most popular Python library. I don't know what the dates are for this. I could easily figure out the minimum and maximum dates inside here to figure out what month these downloads came from, or from what months. Why don't we do that? Here, I'll select, watch this. Let's go to the start of the month, and there was a timestamp column, if I'm not mistaken. And I think it was all caps, timestamp. What does that do? Well, that's going to, whatever the timestamp is, it's going to return the first day of the month. And so if I do project and count from that, let me call this something. Let me call this month, and let me group by month, comma, project. And let's see what happens. Oh, I'm missing the word by. Okay, group by month and project. Trying to go fast as I do this. Let me sort it by the count, which is number 3, the third thing selected. So the third column in the result set. I'll sort by count descending, and we'll see that Bot03 had 13,142 downloads in May of 2023. That's the start of the month. I put all these together in the ones from the same month. So everything from May went into the same bucket. It looks like Bot03 had 11,228 downloads in April of 2023, and so on. So notice what I'm doing here. I'm just running these queries. Now they're taking you might think they're fast. It's 3.28 seconds. That file's got 1.679 million rows in it. Yeah, it's fast, but it's certainly not blazing fast. It's not ClickHouse fast. Why? Well, because the file's in S3, and every time I run these queries, I got to stream the data into ClickHouse. When push comes to shove, when it's time to query your data seriously in ClickHouse, you're going to create a merge tree table and put that data into ClickHouse. And so I'm going to do that. In fact, I'm going to go over to the docs, and we're going to download here. If I go to the example data sets, the UK property prices data set. I'm just going to copy these commands. I'm going to create this table called UK price paid. It has a table engine of type merge tree. And I haven't talked about merge tree yet, but that's the real payoff in ClickHouse. That merge tree table is the one that has all the column storage, the parallel processing, the fact that it uses all the memory, the fact that it can be split across multiple shards on different servers and replicated. That all comes from merge tree. Notice I used ClickHouse data types. I didn't have to, but I always do. We'll talk about low cardinality in the modeling chapter. We'll talk about enumerations in the modeling chapter. Looks like there's a lot of string data here. And for whatever reason, I ordered it by postcode 1, postcode 2, address 1, and address 2. I didn't really order it. I just pulled this out of the docs. I just want you to see, this is a great data set. I'm going to paste this in here, and we're going to insert this data. Now, this file is actually from the United Kingdom government. It's on their S3 website. and it's a CSV file. Notice I told ClickHouse it was a CSV file. And we'll go through all of this usage of a table function, this URL table function. We'll talk about that in the data ingest chapter. But I want you to see that behind the scenes, if I go over here and open up a new tab and I select count from UK price paid, that there are that's 5.4 million. Notice I'll use one of ClickHouse's wonderful functions. I love this function. I use it all the time. Format readable quantity. There are 7.57 million rows in this table. And if I go over the other tab, you can see it's still downloaded. I'm going to give this tab a name. I'm just going to call it module 1 since that's what it is. Notice that every couple of seconds, I'm getting about 1 million rows. So there's 11.8 million rows. But if I run this again, well, let's count to 1 here. There's 12.9. So every 2 seconds or so, I'm getting 1 million rows coming in. It's coming in pretty fast. I can certainly query the data. Obviously, I am querying the table right now. Let's just grab some rows. Let me select star from UK price paid. I'll just grab 100 rows. I want you to see what this data set looks like. Like I said, we're going to use this data set a lot throughout this entire learning path of using ClickHouse. These are properties sold in the United Kingdom. Notice there's the price the property was sold. This is the date the transaction happened. The data goes all the way back to 1995. It goes all the way up to present day. These don't have the postcode, but most of the rows have a postcode 1 and a postcode 2. You'll see things that you would expect to see, like the address and the locality and the town, and maybe some of the older data doesn't have some of those details, but most of the data has all of this information in it. And so let's see where we're at. Let's see how many rows we have. We have 28.07 rows. That's about it. Yeah, it's done. The insert is done. Let me run that one more time just to make sure. And we have 28.78 million rows. Took a while to insert. Again, I don't own that bucket, and who knows how far away my instance is from there, but I would say that went pretty fast. And what's nice is if you want to run these queries, let's say I want to know, let's do average price. We talked about average price of cell phones in my very simple example. Let's find the average price from UK price paid. That's 28 million rows, 28.7 million rows. And it took 124 milliseconds to figure out what the average was of all those numbers. Hey, that's not bad. Check this out. We'll do it. What would probably be more interesting is I took the average price per town, because town is there's a column called town. So if I group by town and figure out the average price, hey, that's pretty quick. In fact, that was a little bit faster. I guess I don't remember what the other value was. It was pretty close though, right? Like that didn't take much longer to group by town. Let's order by 1 descending. That'll put the most expensive ones first. And for whatever reason, Gatwick has the highest average prices of towns. We should put count in there. I wonder if that'd be interesting to see. So we have the town. Let's do the count. See how many there are. Gatwick might not. Yeah, Gatwick only had 12 transactions, so the average is pretty high there. I would have thought it would have been something like London or something, but yeah, London's number 22, I guess. So there you go. These are super fast queries. 238 milliseconds. That's very, very fast. Yeah, I think it's a great. I want to show you one more thing. The results come back in a table, but if I click on chart right here, you can create a bar chart or a line chart or a pie chart or something. If you just grab, like, I'll put town on the x-axis and I'll put the average price on the y-axis, and you see, oh, that's really zoomed out. There's one number that's kind of skewing the whole thing. I can put count on there. A count shouldn't be too skewed. Yeah, there we go. Yeah, it's still there's still one town that's really throwing off the values there. So my chart's kind of blurred up a little bit. But nice that you can do that in the SQL console here. Just, very quickly grab a result set and look at it in a chart. All right. So let me go back to the slides. I think I did everything I wanted to show you, at least for now. Like I said, we'll spend a lot of time with this UK property prices data. One of the very first labs oh no, I shouldn't say that. I don't know if you're going to download it right away, but in one of the upcoming chapters, you'll download it and you'll write all kinds of queries to analyze that data. I have a couple of data sets in the lab. Hey, for what it's worth, if you're going to install ClickHouse in production on your own on-prem environment, you're not going to use that curl command. That curl command downloads the absolute latest version of ClickHouse. You're going to use a Debian package or a RPM, a Red Hat package manager or something like that. You'll use Docker, Kubernetes, whatever it is you're using. So keep that in mind. And that's how we started the server. I showed you that. You just do ClickHouse. That's if you're running it locally on your laptop or something, and the ClickHouse client connected to it. Very nice. In the first lab, like I said, we're going to use the cloud. All the lab instructions are written for the cloud. It's super easy to use. It's cost effective. Just go to clickhouse.cloud and log in. It'll be free for the first $300 worth or 300 credits worth. In the second lab, you're going to write some ad hoc queries. We got some Parquet files sitting up in S3. We have some cryptocurrency prices, these transactions. It's crypto data. It's super hilarious, the crazy things that happen with crypto prices. So you'll be able to run these queries on that file. It's not a huge file, so those go really fast. It's a great way to query that data set. And then in the third lab, I want you to download the ClickHouse client in some capacity and run it locally on your machine. Yeah, you're going to use the SQL console a lot, but it's still nice to have that ClickHouse client running from a terminal, no matter what your operating system is. So off you go. If you have any questions, please go to the community Slack and look for that ClickHouse Academy channel. We watch that all the time. It's a great place to get help.